Hello everyone, welcome back to my channel. Hope you all are doing good. Now we are going to talk about how to handle outliers. Now we understood how to detect outliers, we will understand how to handle outliers. And guys, I am putting a lot of effort to make things in front of you, to keep things in front of you, to make each and every concepts understandable. So you won't put much effort to brainstorm yourself. So please start subscribing if you have not done that. All I need is your time. You need to invest your time for your learning. So let us start with the topic for today. Now we will talk about how to handle outliers. We understood all techniques on how to detect outliers. We saw how to do it in box plot. We saw how to create, detect by using G-score, IQR or MED. Now we will understand whatever the outliers we got, right? Whatever the outliers, because outliers cannot be the whole dataset values, right? If you have 500, or if you have 8,000 rows, you will get hardly 50 or 100 outliers most of the time. Or it may vary based on the dataset. How to handle that? So we can take all those outlier values and we can apply these methods to make them or to scale them down. So we will understand that here. So what is the first step, guys? We have to import our libraries. So we did that. We have taken Seaborn, Matplotlib, Pandas, and NumPy. And this is how we can get your SNS dataset names, right? I had shown you already, but here I have again kept it. Get underscore dataset underscore names. If I'll print this, I'm going to get everything. However, I have taken one dataset which is planets. I have taken planets dataset from my SNS and I am going to show you the example here how to get it. So I have taken load dataset planets. You can see planets is one of the dataset here. Okay, here this one. So the same thing I have taken. So what exactly this dataset contains? It contains method, number, orbital period, mass and distance and year. So I have 6 columns present here. Correct? And method is nothing but by which method it is, revolving around the orbit, right? And the orbital period, that means it is based on a year, I believe, right? Then mass of those satellites, distance, how much distance it is from the orbit. So all those things it has taken all the details, or we have all these details present. Next step is what? We have to get the info of that. So you can see I have almost 1035 entries and these are my indexes 0 to 1034 and these are the methods. So I can say by seeing this by seeing this data set, I have orbital period which is 992 and it has null values. Mass is having null values, it is not same to 1035. Distance is having null values. So I am not going to show how to treat null values here, but here I am just showing these 3 are containing my null values. Now I'm not filling all those columns at a time. However, I want to show one example on how to treat outliers for one. So I have taken one particular column which is orbital period. Okay, where I have 43 values are null in that. You can see here clearly orbital period 43. I am taking the mean of it and I am filling it out. Okay, I am filling it out. If I'll take this, I should not be getting orbital period anymore. So let me just take this and run it. So you can see my orbital period is not containing any null values and we are good to go ahead now. Okay, so if I'll data.head, it is still same. Okay, and now, okay, I filled for mass and Mass is also not, like, it's not containing any null. Distance also I have filled with median. And now my data set is not containing any null value. And how to do that? I will check again by that sum method, right? Check this sum method again and come down. It's not containing any null values. We are good. So now I have taken what I did. I have taken bar plot just to understand. Okay, I have orbital period. I have orbital period and I have distance. So I am telling, I want to know what is the relation or how, because I want to know how these features are related, right? Then only I can go ahead and I can pick one feature and I can find out the outliers. So I am just seeing that, okay, my orbital period and distance, how exactly it is present, and I am taking top 50 data right now because here 1000 data are, like, 1000 values are present and I cannot get all at once. So you can see these are your orbital period and these are your distance. So you can see that I have almost 2 values. In this 50, I can see almost 2 values are present, which are really high in number as compared to this. So in this lower range or this range is coming almost around 150. However, this high range is coming around 500. So there is a huge difference, right? So I can say distance can be or the orbital, this is orbital period, right? So orbital period can have my outliers. Because this is a distance. I'm not mapping, or I'm not plotting my distance here. I'm plotting my orbital period. So what is the next step? We can consider my G-score method, and G-score is good for large data sets. So I have taken my G-score for all and I'm calculating it. You can see that I have calculated it. Now I am taking absolute value and I am understanding, okay, my threshold value or my data. My threshold value should be, if my threshold value is 3, which is true, and if any of the G-score values are coming greater than 3, I can consider them as my outliers. So I am getting 3 outliers here based on the above data, and my orbital period is this and distance is this 7.69, 39.94 and 55.25. G-score I am getting 12, 6 and 28. High, it's very high, right, as compared to 3. So what is the next step? These few steps I have written. Once identified, outliers can be treated in several ways. One is the removal. Okay, first we can remove, just the way we saw in our previous example. We can drop or trim. Best for outliers caused by clear data entry errors, measurement errors, or any other data collection mistakes. That can be handled, like if you have these kind of particular errors, like if somebody, because you are going to get data from the from various resources, right, from various sources, and you don't know how those people have collected data for it, and these are the different things you have to do to understand your point of view, right? So there are different ways the errors can handle, or the errors can be present in your data set. One is the data entry errors, right? Measurement errors, if somebody might have entered wrong numbers, right? That can be one of the aspects. Then other data collection mistakes you can remove in that kind of scenarios. Next is imputation or replacing values. Replace with central tendency. Either you can replace with mean value, substitute outlier values with median or mean, right? We are doing it in those cases. Then cap or Winsorise, replace extreme values with specified maximum or minimum value, okay, effectively bringing them within the typical range. So we understood this already, how to replace values, and we did that, right? Now, we saw how to replace values with mean and median by filling the data. Now, if you want, you can take those mean value and you can just replace this value, like which is our, this is your orbital period. And if you want to know what is the mean value of it, let me come back here and get my mean value. Where is it? Yeah. So I need to get mean value. That means I need to get describe, pandas describe method, right? So if I'll do describe, I'll get mean value for my orbital distance, correct? Or if I'll do dot d, it is going to be. So you can see I have mean value, this one, like that means it is having almost 2000 something, the value is going to come. Not 2000, 2 lakhs something it is going to come. So you can replace directly by coming to this, and you can replace these three values directly. That's not a problem. Or else we have these kind of data transformations. You can take those values, okay, apply a function. Okay, apply a function. What are the functions? We have logarithmic, square root, or inverse transformation to the entire data set. This can reduce the influence of outliers by changing the data scale, making it more suitable for statistical methods and analysis. So before detecting or handling these outliers, you can use this method. If you do this method, what it is going to happen? It is going to scale it down. It is going to scale it down to the to your normal value. And how to do that? First is this one, data log value np.log is a method. What I want to transform, either you can take these outliers. Okay, let me take this first and see whether it is coming up. Okay, let me just comment this line and let me take it back again. So first we can see whether we are able to get. No, we cannot take outliers directly because that is a series. If you want to take outliers, that means you can put that in a data frame and you can just try that. What is that method? Orbital out pd dot data frame outliers. So if I'll use this, it should work. Loop of u function does not support zero argument in log methods. This is also data frame, right? Okay, we will see how to apply on over the complete data, because it is not considering that series of data. We will directly take that orbital period and we will get the log value. And after that, we will apply base 10. We have log 10, right? Log 10, 5, log 10, 6. That's how we are getting 10th base of logarithmic, right? So we can get that by applying log base 10 and np.log 10. And if we'll print, this is what we are getting. So we are getting method, okay, number, orbital period, okay. Then now we have mass, then distance, year, g-score. G-score, just ignore this, it's not needed anymore. Then we are getting log value and we are getting log base. And you can see the values are coming much down now, right? It's coming in a single scale. That means now you should not be able to even detect these outliers the way we saw. These up and down values, right? Where is it? Yeah. So we saw it's almost transformed value, correct? Then we can take another concept where we are getting square root of that. So we understood scaling and transformation, right? So Kelling, we are doing fit and transform. So that is also one of the way, before handling or detecting outliers, you can apply these methods. Okay. And you can go ahead and try to understand whether outliers are coming or not. And you can see that now I have taken my square root count. Okay. Then NP dot square root. So all these are mathematical functions, right? So we can get everything in NumPy. So on NP dot square root data orbital period, then I am getting my head. So you can see square root count, it is coming again. You can see it's coming in almost a good range, correct? It's not like so much of difference. Then we have inverse transformation. So we can take in data inverse method. Okay. 1, like you need to divide 1, like with 1, your whole each and every data point, and you should be able to get the inverse method, right? You can see inverse time, inverse method, like that. Okay. And with that, we understood how to apply transformations. Now, we will see, okay, whether we have any more outliers or not by considering, let me just take this, where we are getting our outliers. Okay, here we are treating our outliers. So we got our, let me take this. Now, if I'll understand this. So if you'll consider, okay, then I think I have to treat my distance. Still my orbital period is there. We need to drop orbital period. And let me drop it and see whether we are still getting or not. So guys, we are seeing that from the top that we are still getting our outliers. And what I did, I have dropped these columns, maybe this orbital period and square root count. If I'll drop, and I can check by retaking them, I should be able to get. Now, if you'll see that, where is it? Yeah. So I have dropped those columns. So my data dropped should contain all the data without orbital period. So it is not containing my orbital period anymore. And let me drop G square. So why G score is coming into picture? G score. Let me do that. Let me remove it. And yeah, we are getting this. Now, we will see. Okay, now we have to again, take our G score and see. Not that. We have to take G score. Like this is outliers. We have to get our G score again. Yeah. These outliers. We need to get G score. Yeah, this one. We need to again calculate our G score for the logarithmic value. Let me take this. So here I have to take. Okay, I have taken already. We remove this as also. So I have again, now I have taken my G score. I am calculating G score for log value based, because this is the one which I transformed, right? So if I'll run this, I'm getting these values. Now I have to take absolute and I have to understand whether I have outliers or not. Still it has some outliers, okay? Because I have log value present is 12 and 30, and for that G score, okay, so it is telling, okay, these two are having outliers. Still it is having outliers. So I can again like I can again take this and I can try it. No, I cannot take str or int. Unsupported operand types str and int. Okay, I cannot take that. Okay, no problem. So now what I did, I do not have to, break my head much. I got these two values. Now I can, take, for these two values like 68, 937, I can go and replace my orbital period value directly, right? Or I can just take these two values and we will see what is the log value present for other, like we have some, like we'll get the mean of it. We'll get the mean of these log values and we can replace it, or you can replace the orbital period value for these two in your original data set, right? So that is how we can get it. And if you want to explore more, you can take distance, okay, and you can just see whether you are able to see any outliers or not. If you want to see distance, do we have any outliers? This is how we can get it. Data G score. I should not take data G score. So for this, I am getting so many, outliers for distance. Just the way we saw here in this graph, you can see so many, upward values are there. So like that, guys, you just try these things and understand how these things will work. And there are several ways you can achieve your goal. Okay, so we'll see you in our next video. Till the time, keep practicing, guys. Without that, it is going to be difficult. I mean, these concepts, whatever I'm explaining, it is going to help you in interviews for sure. And I'm very sure that most of the people, like after this, because it's the end of our data science, and after this, you guys can start exploring your job field, and you can see whether you are able to, crack your interviews and give me your feedback on that. Okay. Yeah. So see you in our next video. Thank you. That is all for now. We will cover further topics in our upcoming videos. Till that time, see you. Please start subscribing if you have not done that. People who have done, thank you so much. And like, share your comments, share your feedback, share this channel link to all your friends and near ones who are in need to know this or who are in need to learn this. Till that time, see you. Bye. Thank you.